Communications in space demand the most sensitive receivers possible for maximum reach, while also requiring high bit rate operations. A novel concept for laser beam-based communications, using an almost noiseless optical preamplifier in the receiver, was recently demonstrated by researchers at Chalmers University of Technology, Sweden. In a new paper published in the scientific journal Nature, Light Science Applications, a team of researchers describes a free-space optical transmission system relying on an optical amplifier that, in principle, does not add any excess noise, in contrast to all other pre-existing optical amplifiers. The researchers' new concept demonstrates an unprecedented receiver sensitivity of just 1 photon per information bit at a data rate of 10 gigabits per second. Our results show the viability of this new approach for extending the reach and data rate in long-distance space communication links. It therefore also has the promise to help break through the present-day data return bottleneck in deep space missions, that space agencies around the world are suffering from today, says Professor Peter Andriksson, head of the research group and author of the article together with PhD Ravikiran K. Substantially increasing the reach and information rate for future high-speed links will have big implications for technologies such as inter-satellite communication, deep space missions, and Earth monitoring with light detection and ranging (LiDAR). Systems for such high-speed data connections are increasingly using optical laser beams rather than radio frequency beams. A key reason for this is that the loss of power as the beam propagates is substantially smaller at light wavelengths, since the beam divergence is reduced. Nevertheless, over long distances, light beams also experience large loss. For example, a laser beam sent from the Earth to the Moon, around 400,000 kilometers, with a 10 cm aperture size, will experience a loss of power of around 80 decibels, meaning only 1 part in 100 million will remain. As the transmittable power is limited, it is of critical importance to have receivers that can recover the information sent with as low power received as possible. This sensitivity is quantified as the minimum number of photons per information bit necessary to recover the data without error. In the new concept from Chalmers, information is encoded onto a signal wave, which along with a pump wave at different frequency generates a conjugated wave known as an idler in a nonlinear medium. These 3 waves are launched together into the free space. At the receiving point, after capturing the light in an optical fiber, the PSA amplifies the signal using a regenerated pump wave. The amplified signal is then detected in a conventional receiver. This approach fundamentally results in the best possible sensitivity of any pre-amplified optical receiver and also outperforms the all other current state-of-the-art receiver technologies, says Peter Andriksson. The system uses a simple modulation format encoded with a standard error correction code and a coherent receiver with digital signal processing for signal recovery. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.